let's do some more problems based on this formula, sine squared plus cos squared is equal to 1, and how they can frame questions into substitution problems. Right, I want you guys to remember these 4 general formats. Okay, based on this formula, they can give you questions connected to sine inverse and sine inverse. This can be a more particular problem where x can be directly taken as cos theta, and here is a function. Alright, and there can be another 2 problems, that is cos inverse and cos 1. These are the 4 questions or 4 type of typical questions they can frame based on this one formula. So if I have a question like y is equal to, let's say, sine inverse of root of 1 minus sine inverse of x, the whole squared. Now look at that. Alright, so this guy looks like what? The second type here. Right, if it is given to you like this, the direct one, if it is a sine inverse of root of 1 minus x squared, we knew how to do it. We did it in the last video, right? Let's take x as cos theta and you get the answer. All right, now in this case, this guy has to be cos theta, right? What is the frame? How do I remember? What is the logic basically here? That this whole thing inside, including the root, should become sine, so that I can cancel this sine inverse with that sine. This is what used to be there in your head. All right, now go ahead with this. Now if at all I take sine inverse of x as cos theta, that's my substitution. Or I can write sine inverse of x is cos theta. So what happens? So I can write cos theta the whole square. Yep, so that goes like sine inverse of root of 1 minus cos squared theta. So who's this guy? What is 1 minus cos squared theta? That is sine squared. So like sine inverse of root of sine squared theta. It goes like sine inverse of root of, okay, I can cancel the root and the square here. It becomes sine theta. That's it. Yeah, cancel these guys, and y is equal to theta is what I have. Now is what I have to do called differentiation of this guy. It becomes very easy with this substitution. My new question is y is equal to theta. Now who's theta? I'll get theta from here. Can I put cos on the other side? It will get y is equal to cos inverse of sine inverse of x. That's it. Now how to differentiate this? There's a simple chain. Yeah, the first chain is cos inverse and the next is sine inverse. So dy by dx would be what? How do I open cos inverse? Minus 1 by root of 1 minus what all is inside this guy, that is sine inverse of x whole squared, right, into differentiation of sine inverse of x. Yeah, what next? 1 by minus 1 by root of 1 minus sine inverse of x whole squared into 1 by root of 1 minus x squared. Okay, that's your answer. Very simple. Keep it in mind what we are, what is the basic frame. What we need to keep in mind is that if sine inverse is here, this whole thing has to become sine somehow to cancel the sine and the sine. All right, keep this in mind. Let's do a couple of more problems. You can generate your own problems here. Anything you would like to fill in this place. All right, anything you would like to fill in this place. Yeah, let's talk about a little more complicated. Let's say x squared plus 3 the whole squared. All right, so what happens here? I can just take this as, I can take this as what? My substitution becomes x squared plus 3 is equal to cos theta. That's it. So that becomes cos theta here, cos theta whole squared. So this is the same till here. Then here now, what is theta? The only thing will change here is this. What is theta? Put cos inverse on the other side. That becomes cos inverse of x squared plus 3. Correct? X squared plus 3. That's it. Now here would be what? X squared plus 3, and I got to differentiate x squared plus 3. That's it. So what happens here? That is x squared plus 3, and differentiation of x squared plus 3 is what? 2x, and that's it. All right, any shortcut we can see so that we can do this problem in, let's say, 10 seconds, maybe a CET question where I am supposed to differentiate this guy in 1 minute, all right, without thinking, or sometimes a shortcut, any trick. Look at this. What I can do is, whenever my question looks like that, sine inverse of 1 minus some function whole squared, so what I do is I'll just take this as my substitution. See, I'll just get the problem out easily in 10 seconds time. So what am I doing is I'm taking x squared plus 3 as what? Cos theta, and just take cos on the other side. That becomes theta is cos inverse of x squared plus 3. Differentiate this guy, that'll be your answer. That's it. See, look at this. All right, differentiate this guy. That is 1 by root of 1 minus x squared plus 3 whole squared into 2x. Is this not your answer? Exactly. It means you can skip the whole thing. Maybe in CT you don't require to show the steps, but you need to know the answer. So if you know this format, that whatever substitution I do here, all right, if it looks, my question looks like this, whatever substitution I do here, I just need to take theta alone and differentiate this guy. That is my answer. That's it. Okay, now let us do another problem based on that. What if I have tan inverse of x here? Let's say I have tan inverse of x. Okay, that's my question. And what can be my answer? 10 seconds time. So what I do is, if this is looking like my general format, that is sine inverse of root of 1 minus a function whole square, I got to take that function, that is tan inverse of x, as cos theta, and separate theta. That is what? Theta is cos inverse of tan inverse of x. That's it. Now if I differentiate this guy, that is my answer. All right. So what is it? That is 1 by root of 1 minus tan inverse of x the whole squared into 1 by 1 plus x squared. See, I get the answer very straight in just 2 steps. These are the tricks which will be used in solving problems in CET or IIT or stuff like that. Okay, so let's go ahead and see how to do problems on this guy, that is cos inverse. It has to be the same thing. Instead of sine inverse, I have a cos inverse here. So any function comes here, that should become sine theta this time, because 1 minus sine square theta would become cos theta. All right, so let's do a couple of problems here and cut this topic. We'll go with the next formula and next type basically, and see how to do problems with. Again, in this the third and the fourth thing, if at all they give you y is equal to cos inverse of root of 1 minus x squared, so I can take x directly as sine theta. And what happens to the form? It becomes cos inverse of root of 1 minus sine square theta. We did this in the last video, right? So anyway, this is cos inverse of root of cos squared theta, and you'll get cos inverse of cos theta, and that's it. Theta is what you have. Who's theta? Theta back from here. Theta is sine inverse of x. So y is equal to sine inverse of x, and dy by dx would be simply 1 by root of 1 minus x squared. So this is a more simple form of problem. If they don't ask you x, okay, and something else given, let's say you have y is equal to cos inverse of root of, let's say 1 minus root x the whole squared, or let's say don't want root x, let's say e power x, okay, any function inside. So what I'm supposed to do, this guy has to be what this time? So it has to be e power x, has to be sine theta. Very simple. So what happens to my question? That becomes cos inverse root of 1 minus sine squared theta, which looks like cos inverse of root of cos squared theta, and we'll get cos inverse of cos theta, giving you y is equal to theta. Now who's theta? Theta you get back from here. Theta is what? Here, sine inverse of theta can be sine inverse of e power x, and that's it. So I can write y is equal to sine inverse of e power x, and differentiate this guy, you get what? 1 by root of 1 minus e power x the whole square into d by dx of e power x, which you know as e power x only. So we simply answered how many types of problems can they ask into this one formula is only 4. Okay, this is general form, we understand this. If something else comes here, a function, take this as, since there is a sign outside, take it as cos. Since it's a cos outside, take it as sine. That's all about it. We'll keep this general formats here only, and we'll go to the next formula basically in the next video and see how many types of problems they can create or frame using this second formula. All right.